In the vast expanse of our solar system, discoveries await those who dare to seek them. On November 23, 2000, a team of astronomers made such a discovery. They found a new moon orbiting Jupiter. This tiny world, initially designated S2000J10, would soon be known as Chaldene. The discovery of Chaldene was not a stroke of luck. It was the result of dedicated effort and advanced technology. A team led by Scott S. Shepard used powerful telescopes at the Mauna Kea observatories in Hawaii. Their careful observations revealed this faint point of light moving against the backdrop of distant stars. Chaldene is no ordinary moon. It belongs to a class of objects known as irregular satellites. These moons have distant eccentric orbits that hint at a turbulent past. Unlike the large, round moons that formed alongside their parent planets, irregular satellites are thought to be captured objects. They may be asteroids or comets that strayed too close to Jupiter's gravitational grasp. The discovery of Chaldene added another piece to the puzzle of our solar system's formation. By studying these distant moons, we gain a better understanding of the complex processes that shape the planets and their companions. Chaldene is a small, faint world. Its estimated diameter is only about 2.5 miles or 4 kilometers. That's less than half the size of Manhattan Island. Its surface is likely a dark, heavily cratered landscape, shaped by billions of years of impacts from even smaller objects. Because Chaldene is so small and distant, we know relatively little about its composition. Based on its color and the properties of other irregular satellites, astronomers believe it is likely made up of a mixture of rock and ice. It may also contain organic molecules, the building blocks of life. Despite its diminutive size, Chaldene plays an important role in our understanding of the solar system. Its orbit, along with those of other irregular satellites, provides clues about the distribution of mass in the early solar system. By studying these orbits, we can learn about the processes that led to the formation of the giant planets. Chaldene is a member of the Carm group, a family of Jovian moons that share similar orbits. There are at least 17 moons in this group, all of which are thought to have a common origin. The Carm group is named after its largest member, Carm, which was discovered in 1938. What sets the Carmi group apart is their retrograde orbits. This means that they orbit Jupiter in the opposite direction to the planet's rotation. This peculiar characteristic suggests that these moons did not form in their current orbits, but were captured by Jupiter's gravity sometime after the planet formed. The capture of a moon is a complex event that requires just the right conditions. One possibility is that the Carmi group originated from a single parent body, such as an asteroid or a comet, that was captured and then broken apart by Jupiter's tidal forces. The fragments from this breakup then settled into similar orbits, forming the Carm group we see today. Section 4. From Hawaii to the Heavens. The discovery of Chaldene would not have been possible without the Mauna Kea observatories. Located on the summit of Mauna Kea, a dormant volcano on the Big Island of Hawaii, these observatories are home to some of the most powerful telescopes on Earth. Mauna Kea's summit rises nearly 14,000 feet, or about 4,200 meters above sea level, placing it above most of Earth's atmosphere. This high altitude, combined with the dry, stable air above the Pacific Ocean, creates ideal conditions for astronomical observations. The telescopes on Mauna Kea have played a vital role in numerous discoveries, from distant galaxies to planets orbiting other stars. The Mauna Kea observatories are not just a scientific marvel, they are also a place of cultural and spiritual significance for the native Hawaiian people. The summit of Mauna Kea is considered sacred ground, and the observatories operate with respect for Hawaiian traditions and beliefs. Section 5. Mysteries of the Outer System. The discovery of Chaldene and other irregular satellites highlights how much there is still to learn about the outer regions of our solar system. These distant worlds hold clues to the earliest epochs of planetary formation, and their study can shed light on the processes that shaped our own planet. The exploration of these distant moons is not easy. Their small size and faintness make them challenging targets for even the most powerful telescopes. However, new generations of telescopes, both on the ground and in space, are being designed with the sensitivity to study these objects in greater detail. Future missions to the outer solar system may target these irregular satellites for close-up observations. A dedicated mission to the Carm group, for example, could provide unprecedented insights into their composition, surface features, and history. These missions would not only deepen our understanding of Jupiter and its moons, but also provide valuable context for the study of planetary systems around other stars.